Hello ninth grader, how are you? I hope all of you in a good condition right now. Today we are going to continue our learning section on the topic of electric current sources. The best competence of this lesson is to apply the concept of electric circuit, electric energy and power, electric energy sources in daily life, including in alternative energy, as well as the effort to save the electric energy. Before we start to study about the source of electric current, now let's see the famous lemon battery. Let's mix one. We know the battery can be created by two different metals and the acid. The lemon contains citric acid. By dipping two metals to the lemon, we already have the battery. And from the experiment, we can see that one lemon, the voltage is 1 volt. Now, let's connect it to the LED lamp. We can see that the LED is not glowing or still off. Now, how about if we use two lemons? From the experiment, we can see that two lemons, the voltage is 1.8 volt. And after connecting to the LED is not glowing or still off. Now, how about 4 lemons? From the experiment, we can see that 4 lemons, the voltage is 3.5 volt. And after connecting to the LED, we can see that the LED is on. There are two types of currents. One is direct current or DC, the flow of electric current in only one direction. For example, 1 battery or dry cell, 2 voltaic cell, and 3 accumulator or ACU or wet cell. Number 2 is alternating current or AC, an electric current which periodically reverses direction and changes its magnitude continuously with time. For example, AC generator and PLN. Next, electric current source. The electric current source is called an electric element or an electric cell. The electric current source can be defined as all objects that can generate electric current. The source of electric current is an important component that the function is to convert one type of energy, for example, chemical energy into electrical energy. Electric cell. From the picture, we can see the bulb is on because of the source of the electric current or battery. An electric current source is used to create a potential difference at the ends of the electrical circuit. What are the examples of electric current source? There are two types of electric cell, primary and secondary cell. 1. Primary cell. Primary cell is non-rechargeable electric current source. For example, voltaic cell and bright cell, or battery or Lagrange element. Number 2 is secondary cell. Secondary cell is rechargeable electric current source. For example, accumulator or wet element and naked cell. Next, voltaic cell. A voltaic cell is an electrochemical cell that uses a chemical reaction to produce electrical energy. The important parts of a voltaic cell are 1. The anode or positive pole is copper or Cu. 2. The cathode or negative pole is zinc or Zn. 3. A sulfuric acid is a chamber of electrolytes necessary to complete the circuit in a voltaic cell. And the disadvantage of voltaic cell is polarization. Polarization is the formation of hydrogen or H2 bubble on the surface of the anode or positive pole. The chemical reaction of voltaic cell is H2SO4 become 2H plus SO4 minus. When used, sulfuric acid molecule will break down into positively charged hydrogen ion and negatively charged sulfate ions. The improvement of voltaic cell is Daniell cell. The Daniell cell is a type of electrochemical cell invented in 1836 by John Frederick Daniell, a British chemist and meteorologist, and consists of copper pot filled with a copper 2 sulfate solution, in which is immersed on unglassed earthenware container filled with sulfuric acid and zinc electrode. He was searching for a way to eliminate the hydrogen bubble, that problem found in the voltaic cell, or we call it polarization. The chemical reaction in Daniell cell are 1. The reaction at the negative pole. Zn plus H2SO4 becomes ZnSO4 plus H2. 2. The reaction at the positive pole. H2 plus CuSO4 becomes Cu plus H2SO4, and CuSO4 as a depolarizer substance, and the function is to eliminate the hydrogen bubble problem found in the voltaic cell or polarization. Next, wet Lagrange element. The important part of wet Lagrange element are carbon root or C as the positive pole, zinc or Zn as the negative pole, ammonium chloride or NH4Cl as the electrolyte solution, manganese dioxide or MnO2 as a depolarizer. Next, dry Lagrange element or battery. Battery is a device consisting of one or more cells, in which chemical energy is converted into electricity and used as a source of electric current. In its simple form, a battery consists of two different metals, positive pole and negative pole, called electrodes, which are dipped into a base or dry electrolyte. Dry electrolyte of battery is ammonium chloride or NH4Cl solid. The important part of the battery are carbon root or C as the positive pole, zinc or Zn as the negative pole, ammonium chloride or NH4Cl as a base or dry electrolyte, manganese dioxide or MnO2 as a depolarizer, and the potential difference between carbon and zinc is 1.5 volts. Next, accumulator or AQ. Accumulator is an electric current source that can be recharged. Energy change when the accumulator is used is from chemical energy to electrical energy, and when charging is from electrical energy to chemical energy. The important part of the accumulator are positive pole is PbO2 or lead peroxide, negative pole is Pb or original lead, and the electrolyte is sulfuric acid or H2SO4. The state work of accumulator are A. Accumulator when used. The chemical reaction is PbO2 plus 2H plus 2E become PbO plus H2O. Pb plus SO4 minus plus H2O become PbO plus H2SO4 plus 2E. The H plus ions go to PbO2 and the SO4 ions go to Pb until the two poles form PbO, and when the two poles form PbO, then there is no potential difference between the two poles and the accumulator is said to be exhausted. When the accumulator runs out, potential at positive pole or plus equal to potential at negative pole or minus. Positive pole or plus is PbO and negative pole or minus is PbO. This is the picture. Next, when the accumulator charging. The chemical reaction at positive pole is PbO plus SO4 minus plus H2O become PbO2 plus H2SO4, and at negative pole is PbO plus 2H plus 2E become Pb plus H2O. When charging, the electric current is flowed in the opposite direction when the accumulator used. I think that's all for me. Thank you for your attention and God bless you.